For topic two, we're going to look at multiplying fractions first, because if you can understand multiplying fractions, it's going to make division quite a bit easier. So we have topic two, just multiplying fractions. And first up, we have steps for multiplying fractions. So I'm going to read you the steps kind of technically, and then I'm going to show you not really a shortcut, but a trick that's going to make it a little bit easier. So step one, you multiply the numerators and you multiply the denominators separately, and then you simplify the result. So symbolically, that tells us if we have a over b as our first fraction times c over d as our second fraction, we would multiply a and c and put that over b times d as long as b and d aren't zero. Because remember, if b and d are zero, you have division by zero, which is undefined. So you always have to make sure your denominators aren't zero. Now, this is great. This is like the technical definition or the technical steps for what you would do with multiplying fractions. I do find it a lot easier for students if you learn how to simplify as you go. Because a lot of times when you're multiplying, your numerators and your denominators may already be fairly large numbers. And then when you multiply them, they get huge. And it makes simplifying fairly difficult. So when I show you how to do this, I'm going to show you how to simplify out common factors as you go, so that at the end, when you multiply across, you've already got a simplified answer. It just makes it a lot easier because, again, simplifying fractions where the numerator and denominator are really large can be somewhat difficult. So that's kind of what I'm telling you right here. I say it can be very helpful to divide out common factors, top versus bottom, before multiplying across. Okay, so let's get to it. So example two here, it says find each product. Answers need to be written in simplest form. So that just means you want to make sure your final answer is always reduced, okay? So first of all, we have for part A, 2/3 times 5/7. Now, in this case, there's nothing to simplify. So if you look at your numerators, 2 and 5 are both prime. You can't write them as factorizations. 3 and 7 are both prime. You cannot write those as factorizations. There are no common factors in the numerators that could also be divided out of the denominators. So in this case, we really can just multiply across. So if we're going to follow the rules for multiplication, we want to multiply our numerators. So we would take 2 times 5, and we're going to put that over 3 times 7. So we end up getting 10 over 21. And at this point, if you think about it, 10, the only factors of 10 are 2 and 5. 10 and 5 are not factors of 21. So we've further proven that this is as simple as it's going to get. So this is simplest form right here. Okay? I'm sorry, I keep sniffing. My allergies are absolutely in full mode right now. So let's move on to part B. So part B, we have 21 over 25 times 30 over 14. So I can already see a couple of situations where I have common factors that I could divide out. Now, we could go ahead and find prime factorizations for all of our numerators and all of our denominators, but that alone would take a long time. So what I'll generally do is I'll start by just getting my numerator and my denominator set up. So I know my numerator is going to be 21 times 30. My denominator is going to be 25 times 14. And then I'm going to take each number and I'm going to see if there's a factorization, just one factorization of those numbers that I could use. So for example, 21. I know I can think of 21 as 3 times 7. 30, I know I can think of it. Anytime a number ends in 0, it's divisible by 10 and 5. So I'm going to go with 5 here because I notice there's a 5 down here, okay? So I'm going to think of 30 as 5 times 6. So I've just kind of broken my numerator up into some really common factors. Now for 25, anytime a number ends in 5, it's also divisible by 5. So I know I can think of 25 as 5 times 5. And then 14, I could easily think of it as 2 times 7. Now, I know this feels counterintuitive because we're supposed to be multiplying, and here we are breaking things up. But let's look and see what happens. Right here, well, let me do this. Right here, I notice a 7 and a 7 that are in the numerator and denominator. That's a common factor that I can divide out. That tells me that 21 and 14 were both divisible by 7. And so if I divide by 7 here, well, 7 divided by itself is 1. 7 divided by itself is 1. So I've divided out a common factor of 7, which is really helping me in the long run. Next, I notice a common factor of 5. Well, that tells me that 30 and 25 were both divisible by 5, so I can go ahead and divide that 5 out. So 5 divided by itself is 1. 5 divided by itself is 1. So let's just clean this up. We're not done, but we're getting somewhere. So in the numerator, I just have 3 times 1 times 1 times 6. So that's 3 times 6. In the denominator, I have 5 times 1 times 2 times 1. So I'm just going to write that as 5 times 2. And now I need to see, is there anything else I could divide out? And it turns out there is one more thing. What if instead of leaving the 6 as a 6, I thought of 6 as 3 times 2? Well, now I see another factor that I can go ahead and divide out. I've got 2's. So that tells me that my numerator and my denominator had another common factor of 2. So 2 divided by 2 is 1. 2 divided by 2 again is 1. So here now, when I multiply, I get 3 times 3, which is 9, over 5 times 1, which is 5. And now 5 and 9 have no common factors. Okay? So technically, that's what I'm going to be doing. Now, I'm going to show you some shortcuts. Once you kind of start to recognize that numbers have common factors, instead of always breaking it down and rewriting it, you can take shortcuts and just immediately divide by a common factor. But for now, I'll just show you this like kind of longer process until we get used to it. So there you have it. We had factors of 7, 5, and 2 that could be divided out of both the numerators and the denominators, and now we have this final answer of 9/5. And just to prove it to you, let's go to the calculator. Now, I am not going to let you just use the calculators willy-nilly. Of course, I've been telling you this from day one. There's a time and a place for the calculator. I want to know that you know how to do basic stuff using a calculator. So I want to know that you can multiply two fractions just very easily on paper, okay? But I do want you to know how to use your calculator too, because for some really nastier kind of, more involved problems, maybe word problems, the calculator would be fine. So let's go ahead and look at the calculator. So we're going to take 21/25 and we're going to multiply it by 30/14 on the calculator and prove that we get 9/5. Now, if you have this graphing calculator, what you can do is you can take this green alpha button and you can hit it first, and then the very first button on your calculator says y equals. If you hit that, it's going to pull up a menu. And you're going to have the option to do n over d, which is numerator over denominator. So you either hit the 1 button to choose option 1, or since option 1 is highlighted, just hit enter. And what that does is it sets up like a template for a fraction. So we want to type in 21/25. And then I want to hit the right arrow. That's going to take me out of that denominator. So I want to then hit times, and I want to do the exact same thing, alpha times y equals. And I'm going to choose option 1 again. And this time I had 30/14. And there you have it. We've proven with the calculator we really do get 9/5. Now remember, the calculator is a wonderful resource at times. You still need to know how to do this by hand, so don't just skip and use the calculator for fun, because I will at some point assess you on how to multiply fractions without a calculator, okay? But there you have it. That's how you would use the calculator if you needed to. All right, let's go back to the worksheet and try the last two examples. Now, for the last two examples, we do have signs we have to take into consideration. So for part C, we have 1 positive times 1 negative. I know that when I multiply a positive and a negative, I'm going to get a negative product. So I'm just going to kind of prepare myself for that negative product, okay? And then down below, I'm going to do the work. So let's see here. We have 6 times 7. We already know it's going to be negative in the final answer, so I'm just going to play with my 6 times 7 for now. And then that's over 77 times 8. Now let's see if we can break these down at all. I know that I could think of 6 as 2 times 3. Now 7 is prime, so I'm just going to leave my 7 as is. In the denominator, anytime you see a number that's like a double digit and the digits are the same, it's always divisible by 11. So 77 is basically 7 times 11. So 7 times 11. And then instead of 8, I'm going to think of 8 as 2 times 4. And now let's see if we have any common factors top to bottom. So starting out, I see a 7 in the top and a 7 in the bottom. That tells me there's a common factor of 7. So 7 divided by 7 is 1, and 1 again. And then I see another common factor of 2. So I have a 2 here and a 2 here. So that tells me I have a common factor of 2 in the top and bottom. So 2 divided by 2 leaves me little footprints of 1. And now let's see what we have left. So for the numerator, I just have 1 times 3 times 1, so that's 3. And then for the denominator, I have 1 times 11 times 1 times 4, which is 44. So that tells me I'm going to get 3/44. 3 is prime. It's not a factor of 44, but we have to always check our signs. And remember, at the very beginning of this problem, I said we have a positive times a negative. That's going to give me a negative product. So this is really negative 3/44. Okay? One more, and then we'll kind of shift gears a little bit. We have negative 4/27 times negative 3/16 times 4/5. So I'm multiplying three fractions. Two of them are negative. One of them is positive. So these two will pair up and become positive. So then I just have a positive times a positive. So I'm going to put a little plus sign here to remind myself that my final answer is going to be positive. Okay, so let's see what this is going to look like. So not even worrying about signs right now, just worrying about numbers. I have 4, 3, and 4 in the numerator. The denominator is 27, 16, and 5. So let's see if we can find any common factors. I think I'm going to leave my 4s alone in the numerator because I see that I have a 16 in the denominator. And so we're going to those 4s are going to kind of work themselves out. And then my 3 is already prime. So I'm not actually going to do anything at all to my numerator. I'm just going to leave it as 4 times 3 times 4. My denominator, however, I'm definitely going to do some work. I know that 27 is divisible by 3. So I'm going to rewrite 27 as 3 times 9. And then 16 I know is divisible by 4. So 16 happens to be 4 times 4. And then 5 is prime, so I'm just going to rewrite it. Now let's see if we have any factors top to bottom that cancel out, or that divide out is what I should say. So I see right off the bat I have a 3. So I have a 3 in the numerator and denominator. So when I divide the numerator and denominator by 3, 3 divided by 3 is 1, and then in the denominator, 3 divided by 3 is 1. Next, I see a 4. I have a 4, oops, there we go. I have a 4 in the numerator and a 4 in the denominator. That tells me both the numerator and denominator are divisible by 4. So I get 4 divided by 4 and 4 divided by 4. Remember, when you cancel out factors, you're really dividing and you're getting like a little footprint of a 1 left behind. That's why I'm showing you like this so you can see those 1s. And then one more, I have another 4 in the numerator and another 4 in the denominator. So that tells me 4 divided by 4 is 1. 4 divided by 4 again in the denominator is 1. So let's clean up and see what we get. So for the numerator, it looks like everything divided out. But remember, when things divide out, you're leaving these little footprints of 1 behind. So really, technically, my numerator is 1 times 1 times 1. Now my denominator is 1 times 9, which is 9, times 1, which is still 9, times 1 again, which is still 9, and then finally times 5, which is 45. Now always go back and double check your signs. So we had a negative times a negative, which is positive, and then a positive times a positive is positive. So my final answer would be positive 1/45. So that is multiplying fractions. There are definitely some little shortcuts you can take to shorten this process, but for now, especially if you're struggling with this, I think kind of follow these steps for now until you start to feel more comfortable. Once you feel more comfortable, instead of rewriting like this step out, you can just realize, hey, I could divide this 4 into this 16 and get a 4. You can take some shortcuts, but for now, just kind of do it like this. Make sure you understand what is happening. And then once you're really comfortable with the process, you can then start taking some of those shortcuts. Okay? So next up, we're going to look at fractions with exponents.